Hey guys, how are we doing? So in this video, we're going to go over directly proportional relationships. This one is super important. This comes up like every year, okay? And normally it's a 2-mark question saying, what does this data show? What does this graph show? And there'll be loads of lines, but they literally just need you to write directly proportional, if it is directly proportional, and that's your 2 marks, right? So how do we know if it is directly proportional relationships? So data just means like numbers. So let's say I've got 2 tables here of information. I've got forces measured in newtons and extension measured in centimeters. So hopefully this is ringing a bell. This experiment is to do with Hooke's law, okay? Hooke's law, I think about Captain Hook, so you're hooking something, right? So Hooke's law is when you have a spring and what you're doing is you're attaching on or you're hooking on the masses. And we can obviously know that the more masses you attach, the more downward force there is on the spring, the longer it's going to extend by. So that's what extension means. It means the change in length. So we can see the spring used to end here, but now the spring ends down here, right? There's the bottom of the spring before, the bottom of the spring now. So we can see when we added this larger mass, the spring changed in length. The spring got longer, it extended by. So let's say we added a 2 Newton force. It's going to extend by 5 centimeters. At a 4 Newton force, it's going to extend by 10 centimeters. At a 6 Newton force, it's going to extend even more by 15 centimeters. So we want to know what type of relationship is this. So if it is directly proportional, what that means is the force is directly proportional to the extension, right? That's a fast way we can write it in physics. That's what that symbol means, kind of like a fish symbol. So if that is true, what it means is if I double the force, the extension will get doubled. If I triple the force, the extension will get tripled. If I quadruple the force, the extension will get quadrupled. If I half the force, the extension will get halved. So basically, wherever we multiply this side by, we multiply the other side by the exact same number. So we can test that. 4 to 2 means we multiplied by 2. So I see, did the extension get multiplied? So look, when it was 2 newtons, it was 5. When it was 4, it was 10. This side got multiplied by 2. That side got multiplied by 2. So tick. And we check again. When the 2 got multiplied by 3 to give us 6, the 2 was 5, the 6 is 15. So the 5 got multiplied by 3 to give me 15. Tick. So clearly this one here is a directly proportional relationship. The force is directly proportional to the extension. Okay, let's say we had a second set of data, another experiment. When it was 2 newtons, it was 5 centimeters. When the 2 got doubled to 4 newtons, the 5 centimeters got doubled to 10 centimeters. That's pretty good. When the 2 got tripled to 6 newtons, we can see that it's now 20 centimeters. 5 times 3 does not give you 20. 5 times 3 gives us 15. So if this was a directly proportional relationship, we should have had 15 here, like we had here, but we don't. So that is not a directly proportional relationship. This one is just as the force increases, the extension increases. But it's not directly proportional. So if we want to see this on a graph, how it would look like on a graph of force against extension, when we plot a graph of something that is directly proportional, it will always give you a straight line that goes through the origin. And the origin is that 0, 0 mark. Okay, so one way to find it is to look at a graph, straight line through the origin, directly proportional. Or you look at the data and see is one number is doubled, the other number is doubled. Is one number is tripled, another number is tripled. Other directly proportional relationships that you need to be aware of is when you do electricity. We know that the potential difference is directly proportional to the current. That's one big relationship. Also, when you look at forces, we know that resultant force is directly proportional to the acceleration. Okay, so directly proportional relationships you need to be aware of. There's another type of relationship, and this one is called an inversely proportional. An inversely proportional relationship. And it's the opposite. So we said directly proportional, if you multiply one, you multiply the other. And an inversely proportional, if you multiply one, you divide the other. So we can see, if the acceleration, so it's like how fast something's going, if the acceleration was 100 meters per second squared, when 5 kilogram mass there, so let's imagine a car's got a 5 kilogram mass, and that's how much it can accelerate by. If the mass got doubled to 10 kilograms, a much bigger car, we can see the acceleration did the opposite. It got halved, right? Less acceleration. If the mass got multiplied by 4 to give us 20, we can see the acceleration got divided by 4 to give us 25. So let's say I wonder what this missing number is. Here I can see the mass went from 5 to 25. It got multiplied by 5. So what's going to happen to my acceleration is, it needs to do the opposite, it's going to divide by 5. So my acceleration there is going to be 20 meters per second squared. And how that would look on a graph if something was inversely proportional, if we had acceleration and mass. We can see as the mass increases here, the acceleration drops. As the mass increases, the acceleration drops. That's what your inversely proportional relationship will look like on a graph. So please save this video. It's super important you know how to do this in your questions.